Okay, question 5. Thrust of 6,000 newtons applied to a speedboat of mass 1,500 kilograms produces an acceleration of 2 meters per second squared. What is the drag? Let's call it D on the boat. Well, what I notice there is I have a mass and an acceleration. So I can go straight ahead and use RF equals MA. RF equals 1,500 times 2, so the resultant force there needs to be 3,000 newtons. Now, looking at this diagram, the resultant force on our speedboat will be the forwards force minus the backwards force, which we don't know is D, but we know the resultant force is 3,000. So let's write out that equation again. Resultant force, but put in the 3,000, is equal to 6,000 minus D. Add D to both sides. Let's do this a long way. You could probably do this in one step if you're good at maths. And then subtract 3,000 from both sides. Gives us D equals 6,000 minus 3,000. So D equals 3,000 newtons. Okay. Next one, similar question. Forwards force of 8,000 newtons is applied to a car of mass 2,500 kilograms, produces an acceleration of 3 meters per second squared. What is friction? Let's call it FR for friction. Okay. Once again, I notice I have a mass and an acceleration. Therefore, I can use Newton's second law to work out the resultant force. 2,500 times 3, so the resultant force needs to be 7,500 newtons forwards. Now, some people might be able to look at that and say, okay, well, there's 8,000 forwards. We need it overall to be 7,500. So we need to subtract 500 from that, so FR must be 500. But let's do it the long way. Resultant force is equal to the forwards force, 8,000, minus the backwards force, which is friction. The resultant force is 7,500. Is equal to 8,000 minus friction. Rearranging that gives you friction equals 8,000 minus 7,500. So friction is 500 newtons. Question 7. We have a rocket of 5,000 kilograms, which has an upwards thrust of 200,000 newtons. And that produces an acceleration of 30 meters per second squared. What is the weight? Now the weight is this downwards force, so let's call it W. Once again, mass, acceleration, so I can work out what the resultant force needs to be to produce that. So 5,000 times 30, which equals 150,000 newtons. Once again, you might be able to look at that and know that the weight must be 50,000, but let's do a little equation for the resultant force on this. The resultant force in our rocket is the upwards force, which is 200,000, minus the downwards force, W. Putting in our value of resultant force that we worked out over there tells us that 150,000 equals 200,000 minus W. Rearranging that gives you W equals 200,000 minus 150,000. W equals 50,000 newtons. Last one then, a constant force of 3,000 newtons applied to a car of mass 1,000 kilograms causes it to travel at a constant speed. Explain what other force must be present, what value the force must have. If it's traveling at a constant speed, Newton's first law tells us the resultant force must be 0. Because if there was a resultant force, it'd be speeding up or slowing down, and it's not. We have a car that has a forwards force of 3,000 newtons on it. How can the resultant force be 0? Well, the only way that can happen is if the backwards force is 3,000. Therefore, what's causing that? Friction or drag must be acting on the car. And have a value of 3,000 newtons. What must the forwards force be increased to produce an acceleration of 4 meters per second squared? So we have a car that's 1,000 kilograms. We're asking what must that forwards force, let's call it T for thrust, be increased to? to produce an acceleration of 4 meters per second squared. Now, what we have to assume in this question is that the friction doesn't disappear. It's still backwards force, like we worked out in part A, of 3,000 newtons. So we can then do RF equals MA. Resultant force equals mass, 1,000, times A, 4. Resultant force needs to be 4,000 newtons. Now, looking at that system, the resultant force in that object is going to be the forwards force T minus the backwards force, which is 3,000. But we worked out our resultant force here, so it's 4,000 equals T minus 3,000. Bring the 3,000 across, or add 3,000 to both sides. Gives us that the thrust from the engine must be 7,000 newtons. And if you're getting that answer, well done, because that really would be one of the harder questions on a GCSE type paper. Okay.